Welcome to my YouTube channel. I'm Nwachukwu Daniel. Today we'll be discussing heat energy and calculations under it. This will be the part 1 of it. Please, if you have not subscribed to my YouTube channel, please don't forget to do so. I will appreciate so much. Also, like my video if you enjoy it. Back to the topic, heat energy. Heat energy is a form of energy that causes temperature changes and change of states. Heat energy also causes expansion of length, expansion of area, expansion of volume of a particular metal. What do we mean by that heat energy causes change in temperature? What we mean by that is that when you have a cold water with you and you pour it inside a kettle and start boiling it, either with electricity or with gas cooker or with kerosene stove, whichever means you use to boil your water. When you keep heating that cold water, after some minutes, you will notice that that cold water will start getting warm. Okay? You see now, the heat you have supplied have warmed the water. It has warmed the water and it has made it to be warm. It has changed the water from cold temperature to warm temperature. Now, we also said that heat causes change of states of a particular object, of a particular substance. What do we mean by that? When you bring an ice block is noted to be in solid state of matter. When you bring this ice block and start heating it, and you supply heat either from electricity, with the use of electricity, or with the use of gas cooker or whatsoever means. When you start heating that ice block, what you notice is that that ice block will start melting to liquid. After melting to water, if you continue heating it, it will turn to gas. From that, you have seen that the ice block, which is a solid state, has successfully converted to liquid state, and also it has successfully converted to gaseous state, which are the 3 states of matter: the solid, the liquid, and the gas. It is also noted that in life, when you have a particular water, it is noted that in life, when you have your hot water, maybe you boil your water to 100 degrees and it is 100 degrees. Okay? Now, you carry your cold water, which is 2 degrees, for instance. You carry your cold water and pour inside your bucket. When you pour it inside your bucket, you notice that this is the cold water you poured inside your bucket. And this is the hot water you boil. When you carry this hot water and start pouring it inside that cold water in the bucket, this is the bucket. When you carry the hot water and start pouring it inside this bucket, you notice that something will happen as a scientist. The cold water will start getting warm, whereas the hot water will start getting colder. It will not remain hot as it is. The hotness of the hot water will start reducing. Also, this is what happens. It means that heat is transferred, or heat energy is transferred from hot water or hot body to cold body. Okay? This heat energy that can be transferred from hot water or hot object to cold object. It can do so by conduction, convection, or radiation process. So we have established a fact that heat energy only moves from hot object or hot substance to cold substance, as you can see. So this substance, this hot water, as it gets to this cold water, the temperature of the cold water will increase to this point, while the temperature of this hot water will reduce to this point. This is called the final temperature or the equilibrium temperature. This temperature of the water now is that temperature you notice when you put your hand inside that already or your former cold water. When you put your hand inside that cold water that you have poured the hot water, when you put your hand inside it, you see that it will be warm or even hot, so to speak. So heat energy is transferred from hot object to cold object. Okay? Another point we need to know is that there are some terms we need to define. One is heat capacity. Heat capacity is called capital C. Heat capacity is that quantity of heat required to raise a substance to 1 degree Celsius. Is that quantity of heat required to raise the temperature of a substance to 1 degree Celsius. Quantity of heat, 1, required to raise the temperature of a substance to 1 degree Celsius. It is noted to be capital C equals to the quantity of heat required to raise the temperature of a substance to 1 degree Celsius. Okay? Now, there is another one that is called specific heat capacity. That is denoted with small letter C. This is the quantity of heat required to raise the temperature of a unit mass. This is the quantity of heat required to raise the temperature of a unit mass of a substance to 1 degree Celsius. Remember, in heat capacity, we do not say a unit mass, but we say a substance. But in specific heat capacity, we say the temperature required to raise a unit mass. That unit mass should be underlined. The temperature required is the quantity of heat required to raise the temperature of a unit mass of a substance to 1 degree Celsius. That means that small letter C is equal to this all over m theta. The quantity of heat required to raise the temperature of a unit mass of a substance to 1 degree Celsius. Whereas this one is the quantity of heat required to raise the temperature of a substance to 1 degree Celsius. So the unit of this is joule per Kelvin, while the SI unit of this is joule per kilogram per Kelvin. That is for this C. This is the unit, this is the unit. From these two definitions, you can deduce that from here, it implies that here, if this multiplied, it will give you C theta. From here, if this multiplied this, it will give you Q equal to MC theta. This tells us that when you compare this formula to this formula, this is Q, this is Q, this is theta, this is theta. That implies that C is equal to MC. Therefore, heat capacity is equal to product of mass times specific heat capacity. Please, let's have it in our mind, okay? Now, we go to the next one, latent heat of fusion. Latent heat of fusion. It is noted with LF. This is different from these two we explained. Okay? Latent heat of fusion is that quantity of heat required to convert 1 gram is the quantity of heat required to convert 1 kilogram of a solid substance to liquid. Quantity of heat required to convert 1 kilogram of a solid substance to liquid. So the quantity of heat required for you to convert a solid substance to liquid, that we call latent heat of fusion at constant temperature. That name, constant temperature, very important. Quantity of heat required to convert a solid substance to liquid, or to change a solid substance to liquid at constant temperature. Okay? That at constant temperature, very important. What do we mean? It means that for a solid substance such as ice block to get converted to liquid, it must be at the melting point of ice block. Remember that a pure water that is in ice form, that is ice block form, a pure water that is in solid form, that is ice block form, that it melts at 0 degrees Celsius. So it is at 0 degrees Celsius that this latent heat of fusion acts on it. It is at 0 degrees Celsius that the latent heat of fusion starts converting a solid ice block to liquid. That means that latent heat of fusion is simply a hidden heat. Latent means hidden. So latent heat of fusion simply means a hidden heat. A heat we cannot see, but it acts. So it acts in a pure ice block at 0 degrees Celsius. Okay? So when it acts in that ice block that is in a solid form, it will change it to liquid, and that is what we are talking about. Then we go to the next one that says latent heat of vaporization. Latent heat of vaporization. This is the quantity of heat required to convert 1 kilogram of a liquid substance to gas or vapor. This is the quantity of heat required to convert 1 kilogram of a liquid substance to gas or vapor at constant temperature. This latent heat of vaporization also takes place at constant temperature. The way latent heat of fusion takes place at constant temperature, latent heat of vaporization also takes place at constant temperature. What do we mean? Let's say we have a pure water with us. For this pure water to start boiling or to be converted to gas, it must be at 100 degrees Celsius. That means at 100 degrees Celsius, which is the boiling point of pure water, we say that latent heat of vaporization will act there. Okay? That is where. But when the water is not pure, the latent heat of vaporization will act at a higher temperature, more than 100 degrees. It will act at a temperature greater than 100 degrees because the water is not pure. But as far as the water is pure, the latent heat of vaporization will act at 100 degrees. It will convert that pure water to gas at 100 degrees. So the constant temperature that the latent heat of vaporization will act is at 100 degrees. Latent heat of vaporization is noted to be equal to quantity of heat all over M. 1 kilogram of that liquid substance. Okay? Now, as we go into calculation in this heat energy, there are some terms, important terms we need to have in our minds. What are those terms? Note that 1 calorie equal to 4.184 joules. Note also that if you want to convert degree temperature from one unit to another, look at the relationship. Degree Fahrenheit minus 32 all over 9 equals to degree Celsius all over 5 equals to degree Reaumur all over 4. This simply means that if they say convert 40 degrees Celsius to Fahrenheit, or convert 40 degrees Celsius to Reaumur. Reaumur and Fahrenheit are one of the units of temperature. Fahrenheit, Celsius or centigrade, Reaumur, they are units of temperature, even Kelvin. So what you do is that to Fahrenheit, you compare this with this. Degree Fahrenheit, you say degree Fahrenheit minus 32 all over 9 is equal to Celsius given to us is 40 all over 5. 40 all over 5 will be giving you 8. It implies that 8 times 9, 72 equal to degree Fahrenheit minus 32. Then degree Fahrenheit equal to 72 plus 32 will give you 104 degrees Fahrenheit. It simply means that 40 degrees Celsius or centigrade is the same thing as 104 degrees Fahrenheit. Then if they say convert to Reaumur, you compare this and this. You say 40 degrees Celsius all over 5 is equal to degree Reaumur all over 4. 4 times 4, it will be giving you 160 all over 5 equal to degree Reaumur. 5 here, 1, 5 here, 3 remainder 1 into 10, 2. That will be giving you 32. So it also means that 40 degrees Celsius is equivalent to 32 degrees Reaumur. Then if they say convert Celsius to Kelvin, convert 40 degrees Celsius to Kelvin, you use the formula that says degree Kelvin equal to degree Celsius plus 273. Degree Kelvin equal to, what is the Celsius given to us? 40 plus 273. That will be giving you 273 plus 40, 313. 313 degree Kelvin. So when you are asked to convert Celsius to Kelvin, use this relationship degree Celsius plus 273. 40 plus 273, that will be giving you 313 degree Kelvin. Okay? Let's have all this in mind as we go into calculation in full. Okay? Then, what we need to also know is that metals are conductors of heat. What do we mean? Metals allows heat to pass through them. Okay? And we also know that only through the hotter object that heat energy moves from. Heat energy moves from hotter object to colder object or to less hot object. So we need to have this in our mind as we go into calculation, so that we will be able to know which one is losing heat and which one is gaining heat. Don't forget this relationship. That will be very important as we go into calculation. The relationship that says heat loss equal to heat gain. So we need to know which or what lost heat and what gains heat. Only the hotter object will be losing heat and the colder object will be gaining heat. Let's see the question on the board. They say a container holds 2.4 kilograms of water. We say mass of water equal to 2.4 kilograms. At 22 degrees Celsius, temperature of water equal to 22 degrees Celsius. water is placed 0.6 kilogram piece of iron. Mass of iron equal to 0.6 kilogram. That has a temperature of 95. Temperature of the iron equal to 95 degrees Celsius. Assuming that no heat lost by water-ion system, what will be the equilibrium temperature of the mixture? And they gave us this. They said we should get the final temperature. Now, what you ask yourself, this water is 22 degrees Celsius. This iron is 95 degrees Celsius. Between 95 degrees Celsius and 22 degrees Celsius, which one is hotter? You and I know that when the temperature is 95, it's higher in hotness. Whereas when the temperature is 22, it's lower in hotness. So it means that the one that will be losing heat is this one, 95. Iron will be losing heat. Iron will be losing heat. Iron will be losing heat. Then water will be here, 20 degrees Celsius. When you carry a hot iron, let's say you carry hot boiler and put it inside your water, what you notice is that the water will be gaining the heat. When the water gains heat, it will gain the heat and the temperature will increase to this point. Then the iron will be losing heat and the temperature will reduce to this point. So two things happen. One, iron lost heat. Iron lost heat. And the heat it lost is 95 minus theta F. When you subtract 95 and this theta F, you get the quantity of heat it lost in terms of temperature. Then this water gains heat. Water gains heat. As it gains heat, the temperature increases to theta F. So this is the equilibrium temperature. That temperature you notice when you carry that your hand and put inside that water you put inside your bucket. When you put cold water inside your bucket and you carry a heated boiler and put inside it, what you notice after some minutes is that your water will be warm. If you put your hand inside that former cold water, it may hurt you. So it will be warm, so to speak. So the warmness or the temperature of that one is theta F. So this is what they asked us to get. Remember, here is 95 minus this. That gives us the temperature it lost. Then, since this point is greater than this, you say theta F minus 22 degrees Celsius. That will give you the temperature it gained. Okay? Now, remember, heat loss equal to heat gain. Now, heat loss is mc theta. And what is losing heat? Mass of iron is losing heat. C of iron, then change in temperature, equal to mass of water, C of water, and change in temperature. That is it. Mass of iron is given to us to be 0.6. C of iron, from the question they say C of iron is 130. C of iron is 130. Then change in temperature. Change in temperature for that one that is losing heat is 95 minus theta F. Say also, mass of water is 2.4 times the specific capacity of water is 4200. Then times change in temperature. Change in temperature is this one, theta F minus 22 degrees Celsius. Okay? So what will happen is that when you say this times this, it will be giving you 78. Okay? Then 78 times 95. 78 times 95 minus 78 times theta f equals to, okay, 2.4 times 4,200. That will be giving you 10,080. Then 10,080 times theta f minus 2.4 times 4,200. That will be giving us 10,080 times 22. That will be giving us 22,160. Okay? So what you now do is that this times this will be giving us 7,410. 7,410. So what you do now is that you collect like tens. This plus this, that will be giving us 7410 plus 221760. Then equals to 1080 theta f plus 78 theta f. So when you add the two, it will be giving you 10,158. This plus this, 10,158 theta f equals to this plus this, that will be giving you 229,170. So what happened now is that theta f will be equals to 229,170 all over 10,158. That will be giving us 22.6 degrees Celsius. So what it simply means is that when you put that hot iron or hot boiler inside this water that is 22 degrees Celsius, when you put that hot iron inside this water, the temperature of the water, which is 22, will increase to 22.6 degrees Celsius. While the temperature of the iron will reduce. And once it reduces, it will reduce to 22.6. That is, when you put your hand inside that water, the temperature of the water and the temperature of the iron will be the same, and that temperature will be 22.6. That is the final or the equilibrium temperature. Okay? We go to the next question. The next question says, how much heat is required to change 10 grams of ice at -5 degrees Celsius into 150 degrees Celsius? Mass of the ice is equal to 10 grams. Please try to change it to kilograms, 0.010 kilogram. To change this to kilogram, divide by 1,000, you get 0.010 kilogram. Now, ice, the temperature of an ice is always negative. That is why for it to start melting, it has to move from negative to 0, because 0 is greater than negative. Then from 0, it goes on. So what happened now is that they said the ice is to move from temperature of -5 to 150. What matters now is that the ice will move from -5 to 0 degrees Celsius. You get the heat required for it to move from -5 to 0. Now, you get the heat that is responsible at 0 degrees Celsius, which is the latent heat of fusion, which we said that latent heat of fusion always acts at 0 degrees Celsius. So this one is mass of the ice, specific capacity of the ice, and change in temperature. Why this one will be mLs. Then the ice, you also get the heat required for the ice to move from 0 to 100 degrees Celsius. The ice have to move from 0 to 100 degrees Celsius, and the heat required will be mass of water, C of water, change in temperature, because at this stage it is already water form. So it's a mass of water, specific capacity of water, change in temperature. You will not use specific capacity of ice because it's not in water form. We use specific capacity of ice here because it is in ice form. Okay? Then after moving from 0 to 100, you say at 100 degrees Celsius, because we know that as far as it is a pure water, the latent heat of vaporization will act on it at 100 degrees Celsius. That is the hidden heat that always acts on pure water at 100 degrees Celsius. So at that 100 degrees Celsius, as heat start acting on it, it will now be converting it to gaseous form. So we now say mLs, mLv, where this is latent heat of vaporization. Then it will now get from 100 to 150. So heat required to move from 100 to 150, mass of water, C of water, change in temperature. So let's compute that. Mass of ice, mass of the ice and mass of water will be the same because nothing is lost. When you take 10 grams of ice and melt it, the volume you get, the quantity you get in liquid is still 10 grams. Unless atom of it or quantity of it is lost, maybe it's poured away. As far as none is poured away, the quantity of the ice is equal to the quantity of the water. Okay? So mass of the ice is given to us to be 0.01 times specific capacity of the ice is 2100. So the reason why we converted this to kilogram is because this constant they gave to us is in kilogram. Once the constant is in gram, use it like that without converting the gram to kilogram. So once the constant given to you is in gram, use the mass as it is in gram. But once the constant is in kilogram, convert the mass to kilogram so that you will not get a wrong answer. Times change in temperature. Change in temperature means 0 minus minus 5. 0 minus minus 5. That will be giving you 0 plus 5 equal to 5. That is the change in temperature. We now say 5. We now say plus this at 0. Mass is 0.01 times latent heat of vaporization is given to us to be 334,000. Okay? So we now say plus, we come to this point. Mass of the ice is 0.01 times 4200, which is the specific capacity of the water, times change in temperature. 100 minus 0, 100. Then we now also say plus at 100 degrees Celsius, mass of the water is 0.01 times specific heat and latent heat of vaporization is 22.7 times 10 raised to the power of 5. Okay? Then what will happen now is we now say plus this one, mass of the water is 0.01 times specific capacity of water is 4200 times change the temperature 150 minus 100, 50. So once we get this heat, this times this will be giving us 105 plus this times this will be giving us 3340 plus this times this will be giving us 4200 plus this times this will be giving us 22 22700. Okay? Then plus this times this will be giving us 2100. So when you add all of it, you'll be getting 32445 joules. Okay? So 32,445 joules. That is the total heat required for you to convert that ice from the temperature of -5 to 150 degrees Celsius. Okay? Don't make a mistake of maybe convert from here to here only, or convert from here to here only, or convert from here to here. You must start from here to here, plus this, plus this, plus this, plus this. Add them up. Whatever it gives you, that is the total quantity of heat. Don't even waste your time trying to convert your temperature to Kelvin, because after converting your temperature to Kelvin and you subtract, it will still fall down to Celsius. So leave it at Celsius and run your calculation. Okay? Thank you for watching the video. Please don't forget to see the part 2 of this video for more calculation. See you next time. Please don't forget to subscribe the video and like the video if you enjoy it. Thank you.